GCSE paper, this is the higher one, it's only the A and A star grade questions for those students who want to get A's and A stars. Question 1, factorise this, 6y squared take y take 12. Factorise means put it into brackets, there's the answer. If you want to multiply it out to double check in the exam, I suggest you do that to double check, but that is the correct answer. Question 2, you've got a problem here with lots of rectangles and they've made it as confusing as they can. Basically, read the question, it says given that 2x squared, add 3x, take 100 equals 0, calculate the length of the smaller rectangle. So we want to solve that for x, that is the length of the smaller rectangle. It says give your answer correct to 3 significant figures, so that's the flag that you need to recognise to use the quadratic formula, which I've done, and there's the workings for it. One other thing with this question, they only want the positive answer because a width cannot be negative, if that makes any sense. They want that value for x, so it's got to be 6.36 to 3 significant figures. There you go. Question number 3. Here's a triangle ABC. Calculate the perimeter of the triangle. Okay, step 1. Use the cosine rule to calculate AB. When it says calculate AB, then that's this length here. I've renamed the sides because I use them later on. So the cosine rule is a squared, add b squared, a squared equals b squared, add c squared, minus 2bc cos a. Which is what I've done here, so I've renamed the size of the triangle, there you go. So A is 136.536, then to find the perimeter you need to add them all up, which I've done at the bottom, and it comes to that. There's my workings if you want to check through it again. Question 4. The average fuel consumption of a car in kilometres per litre is given by the formula C equals D over F. By considering all the bounds, work out C to a suitable degree of accuracy. Okay, you want to find the upper bound and the lower bound. Here's how I found the upper bound. Upper C for consumption. You've got to make the top number as big as it can be, which, if that's correct to 3 significant figures, it's 163.5, and the bottom number as low as it can be. So when you do the division, the answer will be as big as it is. The lower bound, you've got to do the opposite. So the top number needs to be as low as it could be, and that needs to be as high as it could be to give you that. Give a reason for your answer. I've just put down here, it's 3.6, and I've rounded it to 1 decimal place because that's roughly in the middle of those two, and that will get you the marks for that one. When you do those in the exam, what they're looking for to get you 5 marks is usually 2 marks for that, and 2 marks for that, and 1 mark for your end answer there. Question 5. You've got an arc of a circle. Calculate the area of the shaded region. First of all, what I'd do is find the area of the entire shape. So it's pi times the radius squared, because it's going to be a circle, divided by 360, all the degrees, and multiplied by 35, and that gives you that number there, 1954.77. The area of that triangle is half AB sine C, which work it out is that. So you've got to do the area of the whole lot, take away the area of the triangle, which gives you the area of the shaded region, and it said give your answer to 3 significant figures, which is what I've rounded it to there. Question 6. Okay, question 6. Solve this one. What I've done, you've got to get the denominators the same, so I've cross multiplied here. It's a little bit babyish, but it works. You get your bottom number is 2x squared, add 5x, take 3. Then you can rewrite it because it's that one, take away that. So you do it's add, sorry. So it's 3x add 8x, which is 11x, and 9 add minus 4 is 5. So you get it over that, and that equals 1. I've multiplied both sides by 2x squared add 5x, take 3, because 1 times that is just that. So that's how you've got this line here. Taken off 11x, added the 5, so that's how I've got 0 on one side. Once you've got that equals 0, you can see if you can factorise it, which you can. So for this to equal 0, one of these sides has got to be 0, so x has got to be minus 1, or it's got to be 4, because minus 1 add 1 is 0, 2 4s, take 8 is also 0. Question. Alright, question 7, a little bit of work here for this one. You've got to calculate the length of QR. There's lots of ways of doing it. The way I did it, first of all, was calculate the length SR there, and I did that using the sine rule. And I've relabeled some of the sides here to make the A's and the B work. So there's my workings for that. So that length B is 4.25. So I'll just label that on there, 4.25. This is 8. We know that because that is 8. So they're the same. We can work out this length here because if the whole lot is 14, we take this away. which I've done the sum here, which gives you 9.746325 and so on. And now we can just use Pythagoras to work out QR, because we do that squared, add that squared, and all the rest of it, and there's my workings down the bottom to calculate QR, and it comes to 12.6 centimetres. 4 marks for that one. Question number 8. Calculate the lower bound for the area of the rectangle. So the lower bound of the area of the rectangle, you need to have the width and the length of the lower bounds. That's where they are. Multiply them together, that's your answer, and that's that to 3 significant figures. So 255000. Question number 9, vectors question. Show that OP equals a fifth 2a add 3b. Okay, let's have a look. OP goes from there to there. You're told that that's 3/5 and that's 2/5. Right, so what I've done is to go from B to A up there, it's a minus B add A, or A minus B, which is fine. To go from B to P, it's 2/5 of this. So at 2/5 A, take away 2/5 B, that's fine. To go from O to B, it's just B, so I've got there. So O to P, you want to go along here, which is B, and up there, which we've said is 2/5 A, take 2/5 B. So OP is B, that's the one that's going across, add this one here. Simplify this down a little bit, so for example B, take away 2/5 B is 3/5 B, and that's 2/5 A stays the same. You can factorise this, what's common in that and that? Well, 1/5, so 1/5 outside the brackets, so it's 1/5 2A, add 3B, and that's what we're asked to show. Question number 10. Just a small formula here, it's about bounds again. Work out V to a suitable degree of accuracy. You must show all your workings, and here's all my workings. To find the upper bound, you've got to have the top one as big as you can, the bottom one as small as you can, and for this one, the lower bound, that's got to be as small as you can, that's got to be as big as it can, which is what I've done. There you are. You've got to square root it because it wants the square root, and here are your 2 answers. Round it to a suitable degree of accuracy. I think the obvious there is 1.08, and that's what I've done down there. So they're my workings for question 10. Question 11, a little bit of circle work here. A and B are points on a circle centre O, so they're labelled there. You've got BC here is a tangent, that's fine. AOC is a straight line, so that one is a straight line. Find the angle ACB in terms of x. So ACB in terms of x, they want that angle in there, which I'm just going to shade in for you. Right, first thing I've done. Angle B is x, so I'm going to call that x in there. We know that's 90 because it's a right angle, which is fine. The other angle is also x because this is an isosceles triangle. So we know that this angle in here of the triangle would be 180, take away x, and that's going to give us this angle here. So 180 take away 2x. If that's 180 take away 2x, there's 180 degrees on a straight line. So to find out that one, you do 180, take away this here, and that leaves you with just 2x. So you know that angle in there is 2x. You know that's a right angle, so you want to find that one. So it's 180, take away 90, take away 2x, which you can simplify to 90 take away 2x, and that is your final answer. To express that angle in terms of x. Question number 12. For all the values of x squared add 6x minus 2 equals x add p squared add q. Find the values of p and q. You've got to rearrange this into this form here. So what I've, which is what I said the first thing. So what you've got to do is start by trying to factorise this one. You notice you can't factorise it. So I'm just going to do the first bit, which is x add 3 squared, and that gives you that. So x add 3 squares multiplied out is x squared add 6x add 9. So x squared add 6x equals x add 3 squared take away 9. So that means when you've got x squared add 6x take away 2, that equals x add 3 squared take 9 take away 2, which you can simplify to being equal to this, and this is in the form they wanted it in. So q is this last one, which is minus 11, and p is 3. Nasty one that there for 2 marks. Question number 13. Simplify this. There you go. You can see what I've done. Question B, simplify this one, just basically factorise the top and bottom. You'll notice that there's two things here that cancel, which is that and that. So you're left with 2x and y over x minus y, and that's your final answer. Question 14, calculate bounds again. It's only asked for the upper width this time. The width is this length here it's after. So what you need to do is round 2,000 to its upper bound, so that's 2,500 because it's correct in one significant figure. You want the length to be the smallest it can be, which is 64.45 because it's to 10 centimetres. That equals that, but give your answer to three significant figures, which is 38.8. I've done the lower bound there as well, but I didn't really need to do that. I should have read the question first. So the answer is 38.8 for the upper bound for the width of the field. Question 15, bit of a fiddly one this. First thing I've done, I want to get rid of the fraction, so I've multiplied both sides by 4x add 5. So that, obviously that stays as it is, but this side I've worked out over here, multiply out the brackets and you get that. So that is one of the sides. But also you've noticed you've got 2x add 1 squared. So I've squared it out here, so you get that, but you'll also notice it's multiplied by 5, so it ends up being 20x squared add 20x add 5. So I put this one over here and I put this one over there, and now you start to simplify it. I've taken 5 off both sides, which added 5 to both sides, sorry, to get rid of that, so it brings down to here. I've taken 20x off both sides, which 20x squared off both sides, which get rid of both the 20x's. Then I've taken 20x off both sides, which leaves you with x equals 10, and that is your answer for 5 marks. I will leave that one up there for you. Question 16. Prove that this is a multiple of 4 for all positive values of n. Okay, what you've got to do is multiply out your brackets. So I've done that there, which gives you that. I've multiplied out the next one, which gives you that. Then it is this, take away that. So there we go. But when you do the take away, make sure you put this whole one in brackets, because you get things like the negative makes a plus. So 9n squared, take away 9n, that goes. 6n, take away negative 6n is 12n, and 1 take away 1 is nothing, so it just simplifies to 12n. So any multiple of 12 is also a multiple of 4, because 4 is a factor of 12. And there's your answer for 3 marks. The equation of a straight line, y equals 2x add 1. Write down the equation for the straight line that's perpendicular. So perpendicular is when they cross exactly like that. So they're at right angles to each other. So the first one, find the reciprocal of the gradient. The gradient on it is 2. So the reciprocal of 2 is 1 over 2. But then for it to be perpendicular, it's got to be negative as well. So find the reciprocal, make it negative, so you get y equals a half x. You could put add or subtract anything on the end of that, because it won't change the angle of it. It won't change the slope, it'll just be like that. Question 18. Prove that triangle ALM, which is this one here, ALM is congruent to MNC. I've done squiggles around them so you can see them. A good way to solve this is by using vectors. So for example, because you're told that L, M and N are midpoints of lines which I've labelled, you could say that B to L, I'm going to call it A, so L to A must be A to M I'm going to call B, and M to C must also be B as well, because as we said before, they're the midpoints. So that means that both these triangles share that line, well, that line there and this line there, because that is the same as that, and because this is a parallelogram, that is the same as that. So that's one side they share. They both share this also this side B as well. So that's B and that's B because it's a straight line. And they also share this line here, because that line from LM is A add B, and NC is also A add B. And you can see I've done that at the bottom. So they all must be congruent, because, and I've matched them up and given reasons for it. There's my workings. Question 19, it's probability tree. There are 17 girls and 14 boys in Mr. Taylor's class. Mr. Taylor's going to choose 3 children at random from his class. What's the probability he chooses exactly 2 girls and 1 boy? Because he takes 3 children, you've got to do 3 stages, so stage 1, stage 2, stage 3. If you're familiar with probability trees, obviously girl, boy, girl, boy, girl, boy. Every time you take one person out, the number will get less and less. So for example, that's why I've left it blank here, if he takes a girl first, obviously there's only 30 students left, but if he takes a girl, how many girls are left? Well, that's going to be 16 girls left. If he takes a girl out, how many boys are going to be left? Well, it's going to be the same as 14. This one here, if he takes a boy out first, how many boys are going to be left? 13. And if he takes a boy out first, there's still going to be 17 girls there. You've got to find at the end where you can get exactly 2 girls and 1 boy, and here are the ones I found: 2 girls and a boy, girl, boy, girl, or boy, girl, girl. So you need to add up those 3 fractions, which I've done, and the answer I get is one of those 2. I'm not sure if you can simplify those. It doesn't ask for it to be simplified, so you don't have to. I'll just zoom out a little bit so you can freeze that if you want to see exactly what I've done. Question number 20. Make n the subject of the formula. Let's zoom back in for this one. N the subject. So what I've done is multiplied both sides by 3 add n, so that to get rid of that fraction, so it gives you that. I've taken off 3a from both sides to get rid of some of the a's. I've added n to both sides to get rid of that one there. Then I've factorised it, which you can do to give that. Then to get n on its own, I've divided both sides by a add 1, which gives you that as a final answer. So that is making n the subject. Question 21. For some reason, question 21 is the same as question 18. So refer back to question 18 for the answer to that one. Question 22. Write as a single fraction in its simplest form. You've got to get the bottom numbers the same. When I do these, I like doing the cross thing. I know it's a bit basic, but I find it really simplifies it. So there's your bottom number, and you've got to do that one, take away you've got 2x over 4. You could do, that one, take away that one. So that's what I've got here. Once you do all the taking aways, you end up with this, and that is your final answer. Question part B, write as a fraction in its simplest form. I've done it in the same way. I've done all the cross multiplying here. There's your bottom number. You're doing 3x, so you're doing that one, take away that one, which is here. So 3x take 2x is x, and there's nothing, take away 2 is minus 2 over x squared add x. That's how you do that one. Part C, it's a nasty one this, I thought, but what you've got to do is notice that these bottom numbers are almost the same, but you just need to multiply this one by x to get it to be the same as that one. And we can do that as long as you multiply the top by x as well. So what you end up with is 2x squared, because you times it by x, over x brackets 2x take 3 and so on. Now the bottom numbers are the same, you can just do 2x squared take away 7, and you put it over that. And over here I've multiplied out the bottom bracket as well, just to make it a bit clearer. So that there is your final answer. Question 23. Use algebra to prove the sum of 3 consecutive whole numbers is always divisible by 3. What I've done, I've called the first of the consecutive numbers n. It could be any number. So the number after that must be n add 1. Then the number after that must be n add 2. So add them up. N plus n add 1 plus n add 2 gives you 3n add 3. If you factorise that, because 3 is common, so you can put 3 brackets n add 1, so it must be divisible by 3 because it's a multiple of 3 there. And that's how you do those ones. Question 24. Explain what's meant by a random sample. A random sample is a sample where everyone has an equal chance of being chosen. That's all you need to write. So for example, pick names out of a hat, alright? So that's nice, easy. Question 25. This is about ratios of surface area and the radius and mass in this case. This is an example here. You've got 2 spheres. The diameter is 6 millimeters and 8 millimeters, so the ratio of the radius is 3 to 4, because the radius of that is 3, radius of that is 4. The ratio of the surface area is when you square these two. So that would make it 9 to 16, because obviously as it gets bigger, the surface area increases disproportionately to the radius, and as does the volume as well, because you've got to cube it to go up. So that's how this sort of principle works. So to go from surface area to mass or volume, first you need to so to go from here to here, you'll need to square root it and then cube it. So what we've done, I'm doing 18 over 50. I've got those numbers from here because they are the surface area. I've square rooted it. I've actually used surds in this case. I found it a lot easier. You cancel the root 2's, so that is that square rooted. Then I'm going to cube it. So I've cubed it. 3 over 5 cubed is 27 over 125. So 27 over 125 equals something over here. This is the mass of this small one we're trying to find out, divided by 500, because 500 is the mass of this one. And that, if you rearrange that, so multiply both sides by 500, that comes to 108 grams. I'll leave that there for you to have a look at, because that is, I think, quite a nasty one to have a look at. Next one, question 26, getting near the end now. Find the gradient of the straight line with the equation 2x take 3y equals 12. Okay, here we go. Right, first of all, we want to get the y's on one side. So what I've done, I've added 3y to both sides and subtracted 12, so it gives me that. I've divided both sides by 3 to get y on its own, and the gradient is whatever the value of x is. So the value of x is actually 2 over 3, so the gradient is 2/3. Part B, prove that a straight line with the equation 2y equals 10x take 3 is perpendicular with the one we've just looked at. The one we just looked at, we know that the gradient is 2/3 because it's up there. So we are going to work out for 2y equals 10 take 3x to be perpendicular. It needs to be perpendicular, you've got to write the reciprocal, so that means it's going to be 3 over 2, but then put the negative. So we know it must be minus 3 over 2. So I've rearranged this one here to get y on its own. So it's y equals 10, take away 3x over 2, and if you look there, it's minus 3 over 2. It's a reciprocal and negative. Nasty one, that. Question 27, the last one. Find the exact solution of x add 3x, x add 3 over x equals 7. This is horrible, this question. Rearrange it like I've done here to turn it into this form here, because we're more used to doing this. Usually if it says give an exact solution, there is a nice whole number for an answer. Unfortunately for this one there isn't. So you've got to use the quadratic formula, which I've done. Here's my workings for it. I hope you remember that the coefficient of x squared is a, coefficient of x is b, which is minus 7 in this case. The coefficient of, well, just c is the extra number at the end. So put your numbers into the formula, here you go. Because it's minus b, and b is a minus anyway, it's minus 7, which is why it turns into a positive 7. Minus 7 squared is 49, because minus 7 times minus 7 is 49. Take away 12, so it's root 49 take away 12, which is 7 plus or minus root 37 over 2. So you get a positive and a negative answer here. Because it's asked for an exact answer, you either need to put the complete answer down, or if you want you can leave it in this form here, because that's probably a more accurate answer. So it's either that or that. And there you go, there's your past questions on the A and A star grade work.